Today's topic will be on using a problem-solving strategy for word problems. So the steps in order to do this is step 1, read the problem and make sure all the words and ideas are understood, and if you have to, read it more than once. Step 2 is to identify what we are looking for. Step 3 is to name what we are looking for and choose a variable to represent it. Step 4 is to translate this into an equation. Step 5 is to solve the equation using good algebra techniques that we've covered in previous videos. Step 6 is to check the answer in the problem and make sure it makes sense. And step 7 is to answer the question with a complete sentence. In this first example, Pilar bought a purse for $18, which is 1/2 the original price. What was the original price of the purse? So, step 1 is to read the problem, which we did, but we also have to understand what it's looking for. So we are looking for the original price, knowing that it's on sale for $18 and is half off, pretty much. So then we have to identify what we are looking for. So what was the original price of the purse? And let's name what we are looking for. So we have to let P equal the original price of the purse, and we can translate this into an equation, which is, and we have to read it again, 18 is 1/2 the original price. So then we get 18 equals, because remember is means equal, so 18 equals 1/2 times P. And then we just simply solve the equation. So we multiply both sides by 2 to get P by itself, and P is 36. Now let's check the answer to this. Does $36 make sense in the problem? Yes, because 1/2 of 36 is 18. You know, a good rule of thumb to think about is whenever you have a problem, if it's asking for how many people, you can't have half a person. So if it's asking for how many people, it's almost always going to be an actual whole number. So that's just to keep that in mind. So that's why I ask if this makes sense in the problem. So in this step 7, let's answer the question. The answer to the question is the original price of the purse was $36. In this next one, let's do another one, but let's include numbers this time. So the difference of a number and 6 is 13. Find that number. So in step 1, let's read the problem, which we had already done. So are all the words familiar? Let's identify what we are looking for now. So we are looking for the number, which is the difference of a number and 6, which is 13. So we have to find the number. Let's name what we are looking for. So we have let n be the number, and let's translate this into an equation with what we know. So the difference of a number and 6 is 13. So right off the bat, we know 6 is 13, so n minus 6, because it's the difference of that number, so n minus 6 is equal to 13. So let's solve this equation. N minus 6 equals 13. Let's add 6 to both sides, and we get n equals 19. Let's check the answer. The difference of 19 and 6 is 13, so that is correct. So the answer to the question is that the number is 19. Moving forward, let's look at consecutive integers. Consecutive integers are integers that immediately follow each other. For example, it could include 1, 2, 3, 4, so on and so forth. Notice, however, that each number is one more than the number preceding it. So if we define the first integer as n, the next consecutive integer is 1. So then the one after that would be one more than n plus 1, so it's n plus 1 plus 1, so on and so forth. So then we have n as the first integer, n plus 1 as the second integer, and n plus 2 as the third integer, then so on and so forth. Let's look at an example. So the sum of 2 consecutive integers is 47. Let's find the numbers. So let's read the problem and let's make sure it's clear what we are looking for. Now let's identify what we are looking for. So we're identifying 2 consecutive integers, that is 47. So let n be the first integer, and then n plus 1 be the next integer, because we are finding 2 integers. So let's translate this into an equation. So we have the sum of the integers is 47, which makes 47 equal to n plus n plus 1, because we have the n in the first integer and the n plus 1 in the next integer. Then let's solve the equation. 47 equals n plus 1. Let's combine the like terms, and we get 47 equals 2n plus 1. And we divide both sides by 2, and we get 23 equals n, which is the first integer. We are not done just yet. So then we have to find the next consecutive integer, which is n plus 1, remember from step 3. So then we plug in 23 for n to get 23 plus 1, and the second integer is 24. So let's check this answer. We have 23 plus 24 equals 47. Does that make sense? Yep. Then let's answer this question. The two consecutive integers are 23 and 24. Moving forward, let's look at consecutive even integers. Consecutive even integers are integers that immediately follow each other. Examples include 2, 4, 6, and 8, and so on and so forth. But notice, however, that each number is 2 more than the number preceding it. Remember, in the last one, it's just one number preceding it. So, if we define the first integer as n, what do you think the next integer is going to be? It's going to be n plus 2. The one after that is 2 more than n plus 2, so it's going to be n plus 2, or n plus 4. So we have the n is the first integer, n plus 2 is the second integer, and n plus 4 is the third integer, then so on and so forth. Now I got a little ahead of myself, but the next part is consecutive odd integers. So these are integers that immediately follow each other that are odd, such as 1, 3, 5, 7, so on and so forth. But notice that these steps actually are the same as in the even. So whether the problem asks for consecutive even numbers or odd numbers, you don't really have to do anything different. The pattern is still the same. Just follow with what the question is asking you. In this example, let's find 3 consecutive even integers whose sum is 84. So let's read the problem and make sure it's understood what we are actually looking for. Then let's identify what we are looking for, which is the 3 consecutive integers. And let's name it. So the first integer is just simply n, the next one is n plus 2, and the next one is n plus 4. Let's translate this into an equation and add all of those together, which will equal 84 in the end. So we have 84 equals n plus 2 plus n plus 4. Let's solve this equation and combine like terms and divide everything by 3, and we get 26 is the first integer. And then we get n plus 2 is the second integer. Remember, in step 3, we have to find all 3. So 26 plus 2, because we have to plug in for n. I was about to say x, but n in this case. And then we get 28 is the second consecutive even integer. Then let's find the third one. So n plus 4, and then 26 plus 4, subbing in 26 for n to get 30. Let's check the answer. Add the 3 numbers, and we get 84 equals 84. Let's answer the question now. The 3 consecutive even integers are 26, 28, and 30.